All right, so Unit 7 of BC Calculus, and these are our review questions. All right, which of the following differential equations proves the slope field? Well, play with it. We got nothing that jumps out at me that says, oh, it's this way or that way. So we'll just start plugging in values. And let's see if I can pull out, nope, can't pull out that. 0 and 0 should give us 0, so these are all good for 0. Let's try 1 and 1. Should give us like 1. 1 minus, that's negative. No. 1 minus 1/3, that's a positive 2/3 possible. 1 plus 1/3, that seems a little steep, so on and so on. This also looks possible over here. So we just start guessing and checking. We should get there. All right, substitution, root x made this integrand. So root x equals sine of y. Y equals arc sine of root x. dy equals 1 over square root of 1 minus that squared x times chain rule 1 over 2 root x dx. Now I'm going to be a little smart here and do that equals 2 root x dy. Happen to notice that root x is sine of y, so I can sub it in here. 2 root x is sine of y. Sine of y equals dx over root 1 minus x. So now we can sub things in. 0 to 1/2. Might have to fix that in a minute, but we'll see. We got to think about that one. And root x becomes sine of y. Dx over root 1 minus x becomes 2 root x dy. So this is wrong. Y of 0, here it is. Arc sine of 0 is 0. Y of 1/2 equals arc sine of square root of x, which is 1/2, which is root 2 over 2. Where does sine equal root 2 over 2? Pi over 4. So this becomes pi over 4. Look around, there it is. 2 comes out front, sine 0 to pi over 4. I don't know why I wrote root x up here. Yes, I did. I can sub this in and make it sine of y. So 2 up front, sine squared y. That's a tough problem. All right, number 3. Gotta do a little integration by parts. Equals x, du equals dx, dv equals e to the 2x, v equals e to the 2x over 2 equals x e to the 2x over 2 minus integral e to the 2x over 2 dx equals x e to the 2x over 2 minus e to the 2x over 4 plus some weird c. Weird, I don't know why I called it weird. Some c sitting out there. Rate at which acreage being consumed. Kudzu, I love that word. Proportional, blah, blah, blah. Okay, gotta do a little math. 3 equals 2e to the negative k times 4. All right, so 3 acres, 2 acres consumed at time t equals 1. 3 acres consumed when time t equals 5. All right, 5 minus 1 is 4. So we kind of combine things here. Let's see if I can make sense of this. Yeah, we start the clock at t equals 1. So this becomes our t equals 0. All right. So we say, hey, that's y of 0 is 2. And we say, they want to know what y of 7 is. And we say this is y of 4 equals 5. So that's where I write this equation over here. Pardon me, 3. All right. So do some magic. We get k equals natural log 3 over 2 over negative 4. We could actually make that a decimal, but whatever. So then we want to know what's going on at 7. By the way, it's not the only way to do this, of course. So it is 2 times t equals 0, e to the ln of 3 over 2 over negative 4. And you should get 4.066 acres. All right. Let f of x be an antiderivative. So this is a straight up calculator. Integral 1 to 5 cosine x to the third dx. We put in 1, we got a 0, so there's a plus 0 out here. Straight up negative 0.293. All right, so 6 integral. So we got this whole partial fractions thing we got to figure out. So that would be 1 over x minus 1, x plus 3. A, x plus 3, b, x minus 1 equals 1. If x equals 1, a equals 1/4. 0, 1 plus 3 over x equals negative 3. B equals negative 1/4. Negative 3, see ya. Negative 3 minus 1, negative 1/4. So we rewrite this integral as the integral of dx 1/4, 4 of x minus 1, plus the integral of negative dx over 4 x plus 3. All righty, we get a 1/4. I'm going to factor that out. ln x minus 1 minus ln x plus 3 plus c equals 1/4 ln of, oh, by the way, these should be absolute values. Apologies for that. Ln of x minus 1 over x plus 3 plus c. It's good math. All right, consider this differential equation. Let's get the solution that passes through the 0.01 and negative 1. So 0, 1 will get you wow, looks like I made a mistake on my original answer key. That's amazing. Pass to the 0.01, 0, 1. All right. It does some weirdness. Looks like it's right on a diagonal here. Something like that. And 0, -1. Weird. All right, this one does this sort of thing. Oh, my answer key is right. When I print these off, they print off wrong. So yeah, this is actually a better way to do this. All right, there's a value for b, which is solution to differential equation. dy dx equals 2. All right, we go up here, we pull this. We say that 2y minus 4x has to equal 2. Sub in 2 times 2x plus b minus 4x equals 2. I'm bothered. We've got 2 x's. How the heck are we going to handle that? Holy mackerel, we got lucky. B equals 1. That's cool math. Let G be the function, satisfies the given differential equation with original G naught. Here's the slope field. G is a local maximum, 0, 0. All right, so it looks like it's got a peak-ish there. Using the differential equation, prove analytically that this is so. All right, cool. dy dx equals 2y minus 4x, which according to the 0, 0 here is 2, 0 minus 4, 0 is 0. Let's take second derivative, prove it's got it's all concave down, so it's got a max min thing going on. First derivative is 0 there. We get d dx 2y minus 4x, which if I'm not mistaken is 2 dy dx minus 4, which if I'm not mistaken, when we get to 0, 0, dy dx equals 0. So at 0, 0, second derivative equals 2 times 0 minus 4, which is -4. So the curve is concave down. And first derivative is 0 there. So and you have a max at 0, 0. I should probably say and dy dx 0, 0 equals 0. Okay, we're getting a little logistic here. I'm going to mess with this equation before I do anything else. 0.2 p times 10 minus p over 10. What just happened? I multiplied that by 10 over 10, made that a decimal, equals 0.02 p. I pulled the 10 out front. 10 minus p. I think that's going to be easier to work with. If p naught equals 3, what's the limit as t goes to infinity of p of t? P naught equals 3. I don't think that matters at all. What's the limit as t goes to infinity of p of t? 10. The max is 10, because that's what that is right there for a logistic equation. That's the max. You can never get bigger than that. This is dp dt. They're asking about the actual value. It starts at 3. Doesn't matter where it starts. This equation tells me the max is 10. Same thing here. Hey, it starts at 20. It's going to come back down to 10. All right. Either the curve's going to be, here's 10. Doing your classic logistic. Or if you start up here, it's going to come back down and go underneath the line and end up there. Doesn't matter where you start. Different population satisfies the separation equation. Find y of t if we give you initial value. Sure, why not? dy over y equals, let's see what I got here. 1/5 minus t over 50. If I distribute this 5, okay, I get 1/5 minus t over 50 dt, which is dt over 5 plus t dt over 50, which I can integrate. I don't have to do any big nasty stuff. ln of y, technically absolute value, but population's all in the positive world, so I'm going to ditch that, is t over 5 plus t squared over 100. Why is that suddenly decided to become positive? I have no idea. Plus c. Okay, plug in 0, plug in 3. All right, now we could look at this and say, oh, c is just ln of 3 because 0, 0. But we like to do this whole thing where we say e this and e all of this, and we get y equals e to the c times e to the t over 5 times e to the negative t squared. I don't even have to do that. I can just go here. It's just a way we do it. Remember that we can break this into, it's an exponent, so this could be e times e to the negative and all that nonsense. We get 0, 0, 1, 1. 3 equals e to the c, so e to the c equals 3. So y of t equals 3 e to the t over 5 minus t squared over 100. That is one answer. There's lots of other ways to do it. They'd all be correct. For the function, part C, what's the limit of y of t? So look at this as t goes to infinity. T squared also approaches infinity. Oops. All right, going back up here, the t squared is going to dominate, so the negative is going to dominate. So we're going to get e to a negative massive number, which means 0. Comes e to the negative infinity, 1 over e to the infinity, 0. All right, flying along here. Spread of a rumor. Hey, that looks like logistic. Yes, it is. Sounds people have heard the rumor. Yeah, math. dy dt, 1.2y, 1 minus y. So this is a carrying capacity. You hit 1, I mean, it basically becomes 100%. Everybody's heard it. Except me, I never hear the rumors. So when it's spreading the fastest, it's half of that. So it'll be when 50% of the townspeople have heard it. All right. Find y explicitly as a function of t. Going to do this with some degree of speed. Because we've got to do the whole partial fractions thing, which is challenging. Get a over y plus b over 1 minus y has to equal this thing right here. Off we go. A times 1 minus y plus b times y equals, again, the 1 up here. Y equals 1 B equals 1, Y equals 0, A equals 1. Hey, isn't that nice? So we end up with 1 over y plus 1 over 1 minus y, integral of y, equals 1.2 dt. My brain's lighting off because there's a negative going to chain rule out here, so I got to be careful. So confused at what I did in my answer key. Just a moment. Got it. All right, so ln of y minus ln of 1 minus y equals 1.2 t plus c. Let's negativize everything so that when I do this, I get the 1 minus y on top. So I'm just going to slap a negative, negative, negative. It's stupid, but it is what it is. So when I combine these, I get ln of 1 minus y over y. Who cares? Yeah, it just makes life a little easier. And the negative c is pointless because it's a constant or variable. It'll all pop out later. E both sides. We get 1 minus y, and we're population world, so we throw away the absolute values. This population can't go negative. Negative c times e to the negative 1.2t. Remember, they're being added so I can break them apart. You know the deal. Hey, find y's explicitly at time 10 equals 0. We are at 0.1. So the initial condition is y naught equals 0.1. So plug it all together, we get e to the negative c equals 9. Put 0.1 in here, we get 0.9 over 0.1, 9. Got a little bit of more algebra crap to do here. 1 over y minus 1, distribute the y, equals 9 e to the negative 1.2 t. All right, add 1 to both sides. 1 over y equals 9 e to the negative 1.2 t plus 1. And I should have put it first. That's how they like to write it. Do that flippy floppy thing. We get y equals 1 over 1 plus 9 e to the negative 1.2 t. Yeah, sorry about that. Didn't write the last part where you could see it. Yes, it's a nightmare. At what time t is the rumor spreading fastest? Well, we know that's when it's 1/2 because we proved that up above. So now we got some more fancy algebra to do, which we really should use a calculator to do all this nonsense for us. Two minus 1 is 1 over 9. ln both sides by ln of 1.9 divided by negative 1.2. T equals ln of 1 over 9 slash negative 1.2. T equals 1.831 days. Wow. Math. Da-da-da-da-da-da. Population of wolves. Boy, I'm getting a little tired of seeing this. I don't know about you. It's like, really? More? Still more? Okay, fine. That's the way they want to be. dBdt equals some k times 600 minus p. All right, proportional, some k. That's it. dp over 600 minus p. Nice, we don't have to do partial fractions. kdt. Negative, because of chain rule, ln of 600 minus p. I thought you said we didn't need absolute values. We don't. T is greater than 0, so I'll throw it out in a minute. Equals kt plus c. ln of 600 minus p equals negative kt minus c. 600 minus P equals e to the negative KT times e to the negative C, which I really should have put out front. All right, we got to figure this out. P naught equals 200. So we get 400 equals pi e to the negative C, if I'm not mistaken. That becomes 1. So now we can just write that in. 600 minus P equals 400 e to the negative KT. Negative P equals 400 e to the negative KT minus 600. P equals 600 minus 400 e to the negative KT. I don't know, it's kind of cool when you can make variables dance like that. It's not easy. It takes time and practice. If P of 2 equals 500, find K. Yeah, because I still get a K over there, don't I? P of 2 equals 500, which is 600 minus 400 e to the negative KT. Whoops, 2. All right, subtract 600 to get 100, divide by 4, negative 400, we get negative 100, get 1/4. Take natural log of both sides. Divide out the negative 2. That's K. I'd leave it like that. But hey, if you're a decimal kind of person, 0.693. Which shockingly enough is the square root, the natural log of 1/2, I believe. But hey, whatever. Final limit is t goes to infinity. P of infinity equals 600 minus 400 e to the negative infinity. No matter what I put in for K, it's pointless. Right? It's only 0.693 times negative infinity. It's negative infinity. So this craps out, and we're just left with 600. What do we got? Wolves? Wolves. Yay, math. Got to be done, right? No, there's one more. Just velocity, skydiver, or parachute opens, velocity, yada, yada. Use separation of variables. Ooh, this is good practice because very few people remember how to do separation of variables. dv dt equals -2 v plus 12. Got to get the v's over here and the t's over there. How the heck should I do? Oh yeah, I can just dv over v plus 12, -2 dt. ln, no chain rule, nothing to worry about here. Speed's constantly increasing, velocity's constantly increasing. Well, not constantly, but increasing. Equals, so I threw out the absolute values, -2 dt plus c. Up we go. V plus 17, we just eat that side, need this side, equals e to the c. I always forget to put it there. This time I remembered. E to the -2t. Initial velocity is 0. -47. Oh no, it's negative. I should be careful with this. Well, we eat it, so it doesn't really matter. That's so lazy. Yep, extremely lazy. -47 plus 17 equals e to the c times 1. Love that initial condition. E to the c equals -30. Therefore, v plus 17 equals -30 e to the -2t. v equals, I guess we'll put it at the end this time, e to the -2t minus 17. Sometimes we're putting the -17 out front, sometimes in the back. Make up our mind. Now we can't do that. V of infinity, what happens? Where's the terminal velocity? Can't keep speeding up forever. Which is why I was like, should always be positive. And it's always positively negative. Weird. Negative infinity minus 17. That'll term, of course, is going to drop to 0. So we just get left with negative 17. Go find our units up here, feet per second. So that's where she'll max out, which frankly is pretty slow. I think you're gonna go a lot faster than that. They must be wearing like one of those suits that slows them down. It's safe to land when her speed is 20 feet per second. At what time does she reach this speed? The second part bothers me. Oh yeah, she slows down when she jumps out of the airplane. Wasn't that fascinating? Oh yeah, it's after her parachute opens. Well, so I'm an idiot, but that's okay. You know, read the full question. Not like I preach that or anything. So here's her velocity profile. All right. Hopefully she opens parachute early enough and then slows down to negative 17 feet per second. What's going on when negative 20? Add 17, 3, divide, negative 1/10. ln sorry about that, becomes positive, over negative 2. T is 1.151 seconds. So as long as she's not a paramarine, jumps out of airplanes in a very bizarre way, she should have plenty of time to get that parachute to, from the time she opens parachute to when she lands. Wow, that's a lot of math. Good luck.